So welcome back to Mastering Solidity. So this is the video series where I'm giving you a crash course in blockchain development. This is video number 7, I'm pretty sure, where I'm going to go over some really critical aspects of blockchain development that you need to understand if you want to build smart contracts, work with Ethereum. All right, so this is really critical stuff. All right, so before we get into that, if you're new around here, hey, I'm Gregory from Dapp University, and on this channel, I teach you how to become a blockchain master. So if that's something that you're interested in, then click the like button down below and click subscribe. And if you want to learn blockchain step by step from start to finish, then I'll show you how to do exactly that. All right, just head on over to dappuniversity.com/bootcamp to get started. All right, and so in this video, we're going to cover a few different topics that deal with working with multiple smart contracts in Solidity. Okay, we're going to talk about inheritance, factories, and then working with other smart contracts. And basically what I mean by that is like calling other smart contracts from inside of a different one, okay? Or interacting with smart contracts, maybe is a better way to say that. So smart contract interactions. All right, so let's get started. What we want to do is create a basic smart contract that handles a secret, all right? And so we'll start off building this inside of my contract. You know, this is the basic smart contract we've been using throughout this tutorial series. So what this contract will do, will basically hold a secret value and allow a user to return the secret value. So we'll start off like this. We'll say string secret. All right, so we'll store the value inside of here, but notice this won't be public. All right, this won't give us a function that reads it. We'll create a special function for that, which will become clear why here in a second. Okay, so let's just create a way to get the secret. We'll say function get secret, and this will be public. View returns. Let's see here, string memory. And then we'll say return secret. Okay. So instead of making this public and getting this function for free, secret function for free, what we want to create a get secret function because we want to restrict who can call this function. And I'll show you how to do that here in a minute. All right. So the next thing I want to do is be able to set the secret, and we're going to do this whenever the smart contract is deployed. All right. So inside of the constructor function, we'll say constructor. We'll say string memory and secret, and then public. Okay. And then here we'll just set the secret like this. All right. So remember, the constructor function inside of Solidity is the function that gets called whenever the smart contract is deployed. It's run once and only once, and it's we create a constructor with this special constructor keyword. It's a function like other functions, but it doesn't get this function keyword with a name. It just uses a special keyword that tells it it's the constructor function. Okay. So that's the basic functionality that we want to implement, but we want to make this a little more sophisticated. All right. So right now, this get secret function, it basically can be called by anyone. So we want to create a modifier like this, where only the owner of the smart contract can call it. Okay. So I think I showed you the ownable pattern in a previous video. Don't worry about like skipping back to that video. I'll refresh you on it right now. So remember, we can create modifiers in Solidity like this. Let's say modifier only owner. Okay. And we can say require msg.sender equals owner. And if it fails, we can say must be owner. Okay. And then we run the function. And then we can put this modifier here. We'll just say public view only owner. All right. And then lastly, what we want to do is set the owner inside here. We want to say owner equals msg.sender. All right, so really quickly, let me just refresh you on what's going on here. So this is a modifier in Solidity, which basically is something we can add to our functions that will get called before this code in the function runs. Like basically, we could just put this here. We could just say, require msg.sender equals owner. All right, must be owner. But it's better to do this inside of a modifier. Well, a lot of times it's common to do it inside of a modifier, and it can be advantageous, especially if you do this kind of thing in multiple functions. All right, let's say like you have multiple functions that could only be called by the owner. You don't want to repeat this line every time. So it reduces duplication to put it inside a modifier like this, and you can just add it to every function that wants to be restricted to who can call it. All right. So we set the owner in the constructor function like this. We just say owner, which we need to store here. Say owner. All right. Address owner equals msg.sender. This is the address that deployed the smart contract. Okay. And then only this person will be able to read the secret. Right. So if I switch to a different account inside of Remix, then they won't be able to call this function, right? It'll throw an exception. So this is really common in Solidity to have an ownership model where someone owns the contract and you restrict what the owner can and can't do. And for that reason, it's really common to use a library. And a lot of times libraries in Solidity are just, there are other smart contracts that can be reused. So you don't want to reinvent the wheel every time you want to restrict the ownership on a smart contract. So a lot of times you'll have a separate smart contract called like ownable or something like that you import into your project, and you create a smart contract that inherits from it, right? So that's one way to work with multiple smart contracts, is to use inheritance, to use libraries, all right? So I'm going to show you how to do that right now. So what you'll do is create a separate contract like this, a contract ownable, and we'll move a lot of the logic related to the ownership into the ownable contract. So we'll put the owner there. Okay, oops, sorry. Put it here. And then we'll put the modifier in there as well. Oops, sorry. There we go. And then what we'll also do is add this line inside of there. But here's where it gets tricky, okay? We have to create a constructor inside the ownable contract, okay? But we don't want to run both these lines. All we want to do is run this line, okay? And we don't want to accept a secret argument because we don't need that in here. So how do we tell, how do we call this line inside of this contract? Well, we say super, all right? So super, what it does is it calls the constructor of the smart contract that it inherits from, like this constructor function, and you can call super in specific places. So, it doesn't really matter in this case. We could call super here, but sometimes the order does matter, and it's nice to be able to call super in an explicit place, okay? So the last thing we need to do is say, we need to actually inherit. So we'll say is ownable. All right, and that allows the smart contract to just inherit from ownable like this, all right? So now all of the ownership logic has been abstracted away into a separate smart contract, and we can just pull it into this one. And yeah, that's how it works. Basically, we could have multiple functions that are, we restrict who can call it based on the ownership. We could have multiple smart contracts that, inherit from this ownable pattern. It really drives things up and makes it really nice. And this is a very common pattern in Solidity that you need to know if you want to become a blockchain developer, okay? So the last thing I want to show you before we compile this and test it out is how to call smart contracts from other smart contracts, all right? And then how to also create new smart contracts inside of a smart contract, okay? So we'll do this in the same, with the same thing. Essentially what we'll do is we'll move all of this secret storage into a separate contract, okay? We'll call this secret vault. Say contract secret vault. All right. And we'll store the secret inside of there. Okay. And then we'll also, let's see here, we'll return the secret. So this thing can have a constructor too. We'll just move this constructor inside there essentially. All right. Oops, sorry. All right. We won't do super because it's not ownable, right? And then we'll move this get secret function inside of there. Okay. And we'll move the ownership here. Okay. So we've moved all the get secret and all the secret behavior into the secret vault. Okay. So now we want to do is basically make this contract sort of a proxy for the secret vault. And this is called a factory pattern, basically where a contract will create another smart contract. And I guess really a factory is a case where a smart contract will create multiple new smart contracts. In this case, it's just going to create one. So it's not a true factory. Like a real factory would create multiple secret vaults and store all of them. And like you could reference each of them. So it's not really a factory, but what it does is it's going to allow us to create a new smart contract and fetch the value from it. It's sort of like a proxy. It's honestly probably not the best demonstration of this, but I think you'll get the idea. And you could research other ways on how you might use something like this, but this is definitely something that is worth understanding in Solidity. Okay. So what we'll do here is accept this secret, and we'll say, we'll create a new secret. First of all, we need a place to store the address. So address secret vault. Oops, vault. Okay. And then like this, we'll say secret vault. I'm gonna scroll up here. All right. Secret vault. Oops. Equals new secret vault, and then pass in the secret. So this is how you instantiate it. Basically, secret vault, the constructor accepts one argument, which is the secret, which we'll create here, and we'll just pass it down whenever we create the new one. So new secret vault, pass in the secret. And then basically we'll create an instance of this like this and assign it to this underscore secret vault variable. And then we'll store the secret like this. We'll say vault address. All right, secret vault. All right, secret. All right, perfect. And then say super. Okay. And then that will create the new secret vault with the secret in it. And now the owner will be the only person that will be able to get the secret. And so we can call another function from a different smart contract like this. We'll say secret vault. Oops, sorry. Equals underscore secret vault. Capital secret vault. Oops. And then pass in the secret vault. Address. All right. So whenever you fetch the smart contract, basically you give it the contract interface, you pass in the address that tells you where it is on the blockchain, and you assign a new variable. Like this. Okay, it's of secret vault type, and then we can say return a secret vault get secret. Okay. All right, so let's see if we can compile that. There may be some errors here. All right, let's just change this, refactor this. All right, perfect. There we go. So let's compile it. All right, there we go. Forgot to call super there too. All right. There we go. All right, so let's compile it, and then let's deploy it. So let's kill this old one. All right, remix. Here we go. So let's put the secret here. We'll say foobar. Okay, click deploy. My contract. We'll try to see the owner. All right, the owner is our current address, right? That's what we deployed it with. And then we'll try to get the secret. Foobar. Awesome. So now let's change to a different account here. And we'll say get secret. And if we look at our transaction log here, or our log here, we'll see that it reverted. So we'll try it again, and there you can see it. All right. So that's how you work with multiple smart contracts inside Solidity. That's how you use inheritance. That's how you create new smart contracts inside of a smart contract. And that's how you call other smart contract functions inside of a smart contract as well. All right. So I hope you like this video. This is definitely stuff that you need to know if you want to become a blockchain developer. All right. So if you haven't already, go ahead and subscribe to the channel. Click the like button down below. And if you want to take that next step and master blockchain step by step from start to finish, then I can show you how to do exactly that. Okay, just head on over to dappuniversity.com/bootcamp to get started. All right, until next time, thanks for watching Dapp University.